Welcome to a video on creating perpendicular lines. We're going to look at two methods to create perpendicular lines. And as you know, a perpendicular line is a line that forms a 90-degree angle, like right here. 90-degree angle with another line. So these two legs of Spider-Man's are perpendicular. Okay, you will need the notes page provided to you to complete this video. We'll do some work on first two sides of the notes page. The sample problem begins with your goal. Your goal is to accurately draw the line that shows the distance from point A, which is 5/8, to the line y equals 4x plus 2. And as we know from the previous lesson, when you're talking about a distance from a point to a line, that distance it can be drawn in many ways, but mathematically the distance means the shortest distance, and the shortest distance is actually the perpendicular line. So let's take a look at that. So method one, we're going to do this algebraically. That means we'll use algebra to create an equation of the line that is perpendicular. So first let's begin with plotting point A, which is at 5/8. So point A should be right here. This is 5/8, point A. Now we're going to draw a line L, which is y equals 4x plus 2. In this line we have the slope 4 and the y-intercept 2. So to draw a line accurately, we're going to begin at the y-intercept. So begin at 2. From there, we're going to use the slope to find the next point. The slope is 4. That really means 4 over 1. So the rise is 4 and the run is 1. So we're going to go rise 4, 1, 2, 3, 4, and run 1 right here. So the next point is here. Now you can draw the line through those 2 points. So there's a line. Use a ruler to do that as accurately as possible. So now the goal again is to find the distance from this point to this line. And again, we know that distance doesn't mean like this distance, it doesn't mean that distance, it means the perpendicular distance, the shortest distance, which is if you make a line here that makes a 90-degree angle here, that's the shortest distance, and that's the distance we want. So the distance from point A to line L is along the line that is perpendicular. It's going to be a perpendicular line. That means a line that makes a 90-degree angle. Perpendicular lines have slopes that are, this might be something you have learned or maybe not. When you have two lines, the slopes of one line and its perpendicular line, the slopes are negative reciprocals. What does that mean? Let's check. So the slope of line L, again, line L has this slope. The slope is right here. The m value, 4. It's actually 4 over 1. So the slope of this line was 4 over 1, right? Up 4 over 1. That's the slope. The slope of the line that we perpendicular to that, so therefore the slope of the perpendicular line is negative 1 over 4. So this slope is the negative reciprocal of this. Reciprocal means flip the fraction. So we flipped it, and then negative means we make it the opposite sign, in this case negative. So there's the slope of the perpendicular line. Alright, so now we're going to create the equation of the perpendicular line. We're going to use algebra to do this. So again, here's the original line, y equals 4x plus 2. Then the perpendicular line we know will look like this. It's going to have a slope that is the negative reciprocal. So this slope is 4, the perpendicular line will have this slope. I'm leaving this thing as a variable here, b, because we don't know what the b value is yet. The b value is the y-intercept. To find this, we'll have to do some calculations. We will find out what b is by substituting the point A, because we want this perpendicular line to pass through point A. So we're going to use point A in that equation. So if this is the equation of the perpendicular line, we're going to substitute this in. Here's your x value. So x is here, so this 5 replaces the x. Here's your y value of 8, so that 8 will replace the y right here. So we've substituted that point. Now all we have left in this equation is b, so we can solve for b. Negative 1/4 times 5 is negative 1.25. Then I'm going to add 1.25 on both sides. And I have b equals 9.25. So now I can rewrite the equation of this perpendicular line right here, because now I know the b value. So here is the perpendicular line. And this is the perpendicular line that will pass through this point. So -1/4 x plus 9.25. So let's go back to the graph and see what happens. Alright, so here's that perpendicular line equation that we just created. Let's see if we graph this line, if it actually is perpendicular to this and passes through this point. So the y-intercept is 9.25. That is right here. The slope is -1/4. So we're going to go down 1/4. The rise is -1 and the run is 4. So from here, down 1 and over 4. Down 1 brings us to 8.25 over 4, 3, 4. Bring us right here. So right here. Okay, now connect those 2 points and you have this line graphed. There it is. We use a ruler and notice the line, it passes through this point because we created this line by using that point. So there it is, passes through that point, and that line, if you look at it carefully, it is definitely perpendicular to the original line. And we know it's perpendicular because of the slope, negative reciprocal. So there we have it. Using algebra, we created a perpendicular line. Now if you were to find the distance from point A, this point, to this line L, line L, or yeah, that's what it's called, line L, then we would just have to measure or calculate that distance there. All right, back to the bottom problems here. Is it perpendicular? Definitely. That's a 90-degree angle where those two lines meet. Does it represent the distance? Yes, it does, because the perpendicular line is the shortest distance. And remember, the shortest distance is the distance we are looking for when we ask for the distance. Okay, now we're going to look at method 2 on the back side. And this method is going to use construction. All right, we're going to construct the perpendicular line. Construction, the word construction in math means you have to use tools. And those tools can be, in this case, a compass. So first of all, there was our point. We have to put that point on there again, right? There was the line that we graphed. It's just the same as the first side. That's the line 4x plus 2. So let's begin with the point and that line. Again, our goal is to create the perpendicular line. This time we're not going to calculate it, we're going to construct it. So here is an animation that's going to show you how to do this construction. It's going to begin right away. Let it finish this here and let it go back to the beginning. So here's the steps. You begin at some point A. Okay, it's going to repeat, give it a moment. So this point A is like our point A here. You're going to take your compass. You're going to make sure the compass is open pretty wide enough that it's more than this distance from A to the line. So it's going to be more than this distance. Put the compass point there and draw an arc here, draw an arc here. All right, and keep the compass the same. And put the compass tip there, draw an arc in the middle. Now turn the compass around and put the compass tip here. There it goes. And then draw an arc that hits that arc also. Now if you use your ruler and connect A through there, that will be your perfect perpendicular line. So you have to repeat these steps over here. If you need to rewatch this thing several times, I understand. Try with your group, let me know if you need some help. So you're creating perpendicular. Once you've made the perpendicular, your job is to check, is that exactly the same line that you were able to create in method 1 when we used the algebraic approach? It should be the exact same line. And at the end then, so again, that's what I just said, you make sure that you've constructed a line that's exactly like what you did on the first side. So does it match? Yeah, it should match. Does yours? And as precisely as you can, create a right triangle. So this is the part now where we're actually finding the distance. You know, we've marked the distance, but we haven't done it. So create a right triangle that will allow you to calculate the distance from point A to line L. And you can do this. You're going to make a right triangle. Remember the technique, make a right triangle, then use the Pythagorean theorem to find the distance. So figure that out now and let me know if you need some help.